Yeah, so we were looking into the circular member. So the S we got it as 1.7. Let's move on. Let's move and see some of the one more. We'll see one more example. So I think you get a better understanding. Okay. Now the example next time what I'm taking here is an most critical tricky one, and even most of the time it has been asked in the examination, GATE examination particularly, of an triangle. Suppose if you are using the triangular section as my beam section, then what is the shape vector for this? Now this is, let's take this as an edge, and also let's consider this as a symmetrical triangle. If you are not clear with my with the drawing, okay, if it is giving you some other intuitions, no, it is an similar triangle. Okay, so symmetrical triangle. So what is my Z here? Now ZE, I know where my neutral axis lies. So Z is equals to I bending about Y max. Okay, so I is equals to what? It is BH cube divided by 36, right? Divided by what is Y maximum? It is 2H by 3. So how much this is? Okay, this is square H is going to get, and you are going to get 3B H square. Okay, so this is 36 times the 2, right? So 3 12s are gone. So the answer is, it is BH square by 24. Okay, let's keep that way. And now I want to calculate my ZP. Now to calculate my ZP, what is my section? This is A by 2. Okay, multiplied by into YC bar and YT bar. Okay, so now the question is where my equal area axis lies. Okay, so remember what is equal area axis? It is an axis which divides the area into two equal parts. Okay, so the total area of the triangle is equals to half into base into height. So I am looking for an equal area axis, okay, where this will be cut down. So actually we don't have that an ready-made answer for that. We need to apply some of the knowledge of triangles. Okay, so let's be this as B, and let's this one as an B1. Okay, and let this be H1. Okay, so what is H1? Now I can have an what is this? I can write this area by 2 should be equals to, see, this area above this one, area above this one should be equals to half of the total area. So area by 2 will be, okay, half into the base is B1, the height is H1. So what is area? So half of will get cancelled. Then what is this area? Then this area is equals to half into B1 into, sorry, B into H should be equals to B1 into H1. Then what I can give you is that, like, B1 is going to be BH divided by 2 times of H1. This is the one relation we are going to get. Okay, so first relation, okay, I'm sorry, I'm not clear. The first expression, B1 is equals to, let's call this expression as 1. Okay, B1 is equals to BH divided by 2 times of H1. Now again, from similar triangular concept, I can write, okay, I can write here, what is this? From similar triangular concept, what I can write, so B by H should be equals to B1 by H1, right? So therefore I can give you what is this b1 is. Okay, so this will give me b1 is equals to bh1 divided by h. Okay, if I equate this, so this is equating 2. Now equating 1 and 2, what I'm going to get, bh by 2h1 is equals to bh1 by h. So bb get cancelled, right? So h square, h1 square is going to be h by root 2. So this is what it is. Okay, so now here I'm not having h square here, it's just h1. So square, it gets h1 square is equals to h square by 2. So therefore h1 will become h by 2. So once I got this one, what I'm going to get, so from this, if you know h1, then what is this b1? Now then the b1 is equals to, okay, so b1 is equals to b into h1 by h. Look at this, h1 by h is equals to b by root 2. So b1 is equals to b by root 2, h1 is equals to h by root 2. You can remember this whenever is necessary. Now let's calculate. Okay, let's calculate. So where this okay, so I have the triangle now here. Okay, I have the triangle here. This triangle is going to be base b1 and h1. Okay, so now area, now here I need yc. Now yc is simple. Why? Because yc is equals to, it is going to be at h by 3 from the base. So therefore it is h by 3 root 2. Okay, this is h by 3 root 2 yc. But problem is calculating the yt. For yt, what I have here is an area. Okay, now this is d1 and this is b. Okay, and this is actually h minus h1. Now to locate this centroid, so what I'm supposed to do, I have to use this formula, that is h minus h1 by 3, okay, multiplied by, it is actually 2 times of b plus b1 divided by, okay, b plus b1. So this is the formula we have. Okay, if I substitute here, so this is what I am going to get. What is h? H1 is equals to h by root 2, right? This is 3 multiplied by, it is 2b, okay, plus b1 is equals to what in terms of b, it is b by root 2, okay, divided by b plus b by root 2. Okay, so what I'm going to get here, I'm going to get, it is h by 3 into root 2 minus 1, okay, divided by root 2. Okay, and again here it is, if you take the common outside, okay, this common outside, you are going to get 2 root 2 plus 1 divided by root 2 plus 1. The whole rooting will cancel. Now this is simply you are going to get bh, okay, by 3. So it is something kind of root 2 minus 1 is there, and here root 2 root 2 plus 1 is there. Okay, so what I can take the calculator and do the okay. If we put everything into here, this is what we get, and putting in the ZP here, this is the value I get it here, and finally substituting for the ESE, I'm for a triangular section, this is what I'm going to get 2.34, and you can see that like it is too much of clumsy a calculation. It's not difficult, but it's only that like it takes a lot of time to do it, and it is advised for you to remember these values. And if I take many of these sections and if I arrange it in an increasing shape factor value, this is how it's look like. The first one is an I section and a hollow circular section, H section, or any rectangular or square section, and solid circular section, and this is rhombus, and this is triangle. So this is how it is. This is the minimum value what we got here. Okay, this is the minimum value what we got here. The I section is having the least shape factor, and the section is having the highest factor. And so having higher values, so these are not actually suitable for sub SN to be SN beam section, because they are not very efficient section. This is what they mean. Okay, that's good, and this is necessary. This is it's an favorite. It's like questions. This usually comes up in the data examination. They can ask you anything. They can give you any 4 sections, and they can ask you in to arrange in a decreasing order or increasing order of S, or they can ask you what is the minimum value, what is the I, what is the S factor for an I section, and also what is the shape factor for a triangular section. They can also ask you anything, and I hope you should be have clarity what exactly we did. I recommend you to solve by yourself, at least not by once, at least by 3 to 4 times, so that like examining the individual every step here, okay, how you got it and why you're getting it, and it will make you clear a lot of things, and so you're not going to make any mistakes in the examination. Okay, so being it clear. And also one more tip for any T section, also for T section also the value will be, for T sections the value will be around S is around 1.6 to 1.8. so any value, we don't have a standard value here because it depends upon the dimensions of the flanges and the web. Okay, so typically you will get an value of S as from 1.6 to 1.8 for the T section. Okay, now moving on, next we have some more definitions in the plastic sections, so we need to know them, and very basic in nature. So the next one what we have here is a load factor. It is, so I just paused the video and just wrote it down just to save the time. Yeah, so load factor is actually defined as it's the plastic moment to the working moment. Okay, so how do I get it? So here the load factor, okay, the load factor is equals to MP by M. What is MPI? We know right now, Fy into Zp, that's the yield stress into the plastic capacity. Now the working moment, it is the allowable stress, like it's not the yield stress. So we remember we actually decrease the yield stress to multiply, like divide by the factor of safety, then we will get it the allowable stress into section modulus. This is actually the section modulus, elastic section modulus. So if I rearrange this one, Fy by F, so what I am going to get, Fy by F, that's nothing but factor of safety, and Zp by Z, it is nothing but shape factor. So this is a very important expression on the relation that is between the load factor to factor of safety and S. Okay, so I think we'll solve 1 or 2 questions on this, so it will make you more clear how and when we will use this load factor. Okay, or else I think I will take up the questions in the question solving session. So first let me complete the complete theory, so then we will come back to visit these things again in solving the problems. Okay, so next we will look into the moment curvature relationship. Okay, so next is moment curvature reach